Hello, everyone. The company we worked with was Dutton, and our capstone project was to conduct research on the feasibility and possible benefits of implementing a full natural language processing pipeline in the Julia language. The use case we focused on for the pipeline was to extract information from CVs for use in an applicant tracking system. Our goal was to use a more robust method than just exact matching of search terms.
As previously stated, our project was based on using the Julia language, a relatively new language compiled at runtime, which has a straightforward syntax and many computation packages in development, as well as a strong parallel computing capability. Previous work has been done on building an NLP pipeline. However, there were several different languages used in the process, so part of our goal was to use a single language as well as to examine the efficiency of using Julia.
The first steps in our project were to gain an understanding of what an NLP pipeline looks like. The steps of a pipeline can be seen here, showing the initial steps were to extract your data, segment it into sentences, check if you need to clean the data, and tokenize it so that each word is separated. After these steps are done, we attempted several approaches to information extraction. These are different methods for the rest of the pipeline steps, primarily statistical and rule-based systems.
The first step we took was to work with a statistical method, running a bi-LSTM CRF model, which is a bidirectional long-short-term memory conditional random field, to do named entity recognition on a test set of 545 CVs. So a bidirectional LSTM is built on the idea that information in certain contexts is meaningless with a one-directional view. For example, in a sentence, if we only look at previous words to try to understand the meaning of a current word, we can get a bad understanding of that word due to the fact that future information can change the meaning. Thus, a bidirectional LSTM model implements separate neurons in a neural network, which take as the input a reversed copy of the normal.
The model implementation was from the text analysis Java Julia package, and while it did provide initial results, it was immediately clear that many entities were not being found, and that some of the information we were interested in, for example, data ranges and skills, were not being extracted. The package had limitations due to using pre-trained weights and a dictionary of terms not common to all resumes. Our goal was to use unsupervised methods for testing. However, the weight generation for the model would require supervised data, which we lacked in our research. Thus, we turned to alternative parts of the pipeline.
The next method we attempted was a rule-based system to classify words. Rule-based systems require extensive logistic knowledge, which we lack, and there are currently no packages in Julia that implement rule-based NLP solutions. But Java and Python do have rule-based parts of speech tagging, and there are packages which allow you to call these languages into Julia. However, when we attempted to use these calls, the PyCall and Java call Julia packages, there were many issues with loading the pre-trained models that were required by these methods. Thus, we eventually decided that a rule-based system in Julia would likely have to be made from scratch, something we did not have the background to create.
We turn to word embeddings, which essentially convert a word into a vector of numeric values. There are pre-trained embeddings such as word2vec and fast text, which are represented by massive matrices, where each column is a vector representation of a word, which has been trained on billions of words. Using these embeddings, we created a model derived from the approximate nearest neighbors method, which would allow for a user to enter a search term, and we would find the k-closest
vectors in the embedding table, and then search the resumes for those which contain the search term.
The idea behind embeddings is that words used in a similar context likely have similar meanings, and thus their vector representation would be similar. For example, if a sentence said, "I'm a focused, hardworking person," and another said, "I'm a driven, hardworking person," the words focused and driven would have a vector representation that had a similar cosine distance. Thus, by calculating the closest matches for search terms and searching for resumes and sentences with those terms, we can create some filtering functionality. We accomplished part of our goal by turning to some basic machine learning methods in an attempt to create functionality that would provide a more robust method for searching CVs compared to an exact matching system. Thank you.